Hello, can you hear me?
Yes, sir.
Okay. Uh, Fine. So right now we're going to start the JEE 2026 course.
Yes,
The plan for this course is uh, we'll be doing 3 classes per week for maths,
yes,
and we'll be starting the course from the basics of the syllabus from the beginning and covering in the entire syllabus. So the first thing that we'll start off with is trigonometry. You are currently in which grade?
sir, 11th, means
You're just
10 to
going
11, both.
You have just finished your 10th boards.
Yes, sir.
Okay, so that is the right time. So we are going to start with trigonometry. The second topic that we'll do is algebra, like parts of it, algebra 1. And after that, we'll go to coordinate geometry.
Okay.
This is the sequence of topics: coordinate geometry, then calculus, and then algebra 2.
Okay.
And there are some more things after that, but right now you don't need to worry about it. Also, uh, for trigonometry, you need one book. You need SL Loney's Plain Trigonometry. Do you have the book right now?
No, not having right now. Having PDF.
Do you have the PDF of this book?
Yes,
So we'll be using SL Loney's Plain Trigonometry to practice this because uh, trigonometry basically has a lot of results and all, and you need to have a lot of practice about it. Otherwise, you'll forget. You'll not understand what is happening. Okay? So
okay, okay,
I will tell you what to do from the book, and accordingly, you have to do the work. Okay. So you don't have to do the full book, but selected topics from the book, selected exercises you will have to do. Okay. Uh, I will send you the PDF also, like if in case you don't have it, but otherwise it should be fine. Uh, for maths, I will send you the PDFs of the other chapters in case you don't have the coaching material or anything. I will send you the stuff and I will send you the documents from which you will have to do the work. Okay. So,
okay,
so you don't need to worry about the study material. It's just that certain books you need to have, like trigonometry, SL Loney, similarly coordinate geometry also. Later, you will need the SL Loney book for this. Some of the books are standard and you need to have them so that you can refer to them whenever required. But otherwise, most of the time, I'll send you the material, whatever is needed. Okay. And the point is that after every class, there will be some homework that is assigned, and you need to work on that homework and come prepared for the next class. Okay. Do you understand what I'm saying?
yes. Sir,
You are a, huh?
screen is not visible.
What?
The screen is not visible.
You have to check your
One
connection.
second.
Something is wrong with your connection, I think. Are you able to hear me?
Yes, sir.
But you cannot see the screen.
No,
1 second, let me just try again.
Today is right.
What?
Yes, it has.
You can see the screen now.
Yes,
Okay. Are you able to understand what I'm talking? Are you able to follow what I'm saying?
yes, yes,
Okay. So we'll start off with the basics of trigonometry. And so far in 10th grade, you have learned a little bit of trigonometry, right?
yes.
You were in which board? CBSE.
Yes, yes.
You have learned about sine
But
theta, cos
I have
theta, tan.
prepared. Yes, I have already prepared for IIT, so I have done that.
Okay. So you know about these ratios, right?
Yes,
So in a right angle triangle, you have learned that sine theta is what here? Tell me.
AP upon AC.
And cos theta is?
BC upon AC.
Okay. So tan theta obviously will be the ratio of sine theta and cos theta. So it comes out to be AB by BC, right?
Yes, yes,
And similarly, you also can define inverse ratios like cosec theta, which is 1 by sine theta, and also sec theta, which is 1 by cos theta, and cot theta, which is 1 by tan theta, right?
yes,
So in 10th grade, what you learn is there's 6 ratios in a triangle. Obviously, you should realize that if my angle theta is here and one more angle alpha is here, sine alpha will be different, right?
yes,
For alpha angle, the perpendicular is this BC, right?
yes,
So you should realize that sine alpha will be BC by AC, whereas sine theta was AB by AC, right?
yes,
Similarly, cos alpha would be AB by AC and tan alpha would be BC by AB.
yes, yes,
So these things are basic definitions of the trigonometric ratios. We also have the Pythagoras theorem, which is AB square plus BC square is equal to AC square.
yes,
And
yes,
from the Pythagoras theorem, what we can do is we can divide both sides by AC square. What happens if I divide both sides by AC square? You can see that this is AB by AC whole square, right?
yes,
So that
yes,
is what? That
sine
is sine
square
square
theta.
theta, right? And similarly, this is what? This is cos square theta.
Cos.
So we are getting this result, which is a standard identity for trigonometry. Okay?
Yes,
Sine square theta plus cos square theta is equal to 1. Also, from here we can get two more identities by dividing sine square theta plus cos square theta is equal to 1. We can divide both sides by sine square theta. You would get 1 plus cos square theta by sine square theta is equal to 1 by sine square theta, right?
yes, cosecant square.
So you'll get the identity 1 plus cot square theta is equal to cosec square theta. And you could also have divided both sides by cos square theta, right?
Yes,
In that case, you would have gotten this sine square by cos square plus 1 is equal to 1 by cos square, right? So that is 1 plus tan square theta is equal to sec square theta, right?
yes,
So there are 3 identities that we have derived here. All of it comes from Pythagoras theorem basically, right? These
oh,
3 identities are super important and something that you have already learned in 10th grade, correct?
yes,
Also, one more thing to notice is you should notice that sine alpha is the same as cos theta, right?
yes, yes,
See, both are BC
cos.
by AC, right?
Yes,
Similarly, cos alpha is the same as sine theta, right?
Yes, sir.
So what we are getting basically is sine alpha is cos theta, cos alpha is sine theta, which means alpha and theta were what kind of angles?
It is right. If you look at 180 degrees.
Alpha and theta are called complementary angles, right?
Yes,
Because alpha plus theta is 90 degrees, right?
yes,
Whenever you have complementary angles, for example, if it was 30, this is 60. If it was 45, this is also 45. Those are complementary angles. If it was 20 degree, it will be 70 degree here, right?
sir.
Whenever you have complementary angles, sine of one of them will be cos of the other one, right? Do you understand what I am saying right now?
Yes, sir.
If alpha plus theta is 90 degrees, sine alpha is cos theta, or you can write it as sine of 90 minus theta is same as cos theta. Similarly, cos of 90 minus theta is same as sine theta. These are the basic rules for complementary angles. And so therefore you can also say tan of 90 minus theta is equal to sine of 90 minus
Cos.
theta by cos of 90 minus theta. So that will be equal to cos theta by sine theta. So that is equal to cot theta, right? So these are the three rules for complementary angles, and this can be shown very easily using a right angle triangle and taking these two angles theta and alpha, right?
Yes, yes.
So this is all the stuff that you had learned in 10th grade. Now what we want to do in 11th grade and the basics of trigonometry, what we want to learn is not just angles less than 90 degrees. Like we want to expand our knowledge of trigonometry to more angles. Okay. So you should realize that sine and cos, these ratios are not just valid for angles in a right angle triangle, valid for right angle triangle. Actually, it is a far more general concept, and what we want to learn is how to figure out what is sine theta, where the theta angle can be anything from 0 degree to 360 degrees. Okay.
Okay.
Do you know about this? How to measure degrees or how to measure the angle?
Um, Maybe anti-clockwise, just take constant from the x direction.
But do you know about this new unit called radians?
Oh yes, where pi to pi, something like.
Yeah. So the point is that uh, it is not just in degrees that we can measure angles. We can also measure it using a new method called radians. So what is this new method? Do you have any idea what this radian measure is?
Not so, but
Okay. So think about this circle. Okay. The circle has radius of r.
okay.
Suppose you are at a point P here. Center of the circle is here. And you go from point P to point Q. Okay. Are you understanding what I am saying?
Yes,
So if you go from point P to point Q, you can connect both the points with the radius from the center to the center, right?
yes,
Correct. Now, what we will say is the angle that is described here, this angle theta, can be written as, obviously, if you can measure the angle in the normal way, you could have measured it, maybe it was 25 degrees or something. Right? But for that, you will have to actually put a protractor here and measure the actual angle and so on.
Yes.
Suppose we have forgotten about the degree measure. Okay, we don't have this degree measure at all. I want to come up with a new way to measure this angle. Okay, do you
Okay.
understand what I'm saying?
Yes, I understand.
I'm not going to use the degree measure now. I'm going to define a new way to measure this angle. So the way people have defined it is the angle theta in radians is referred to as the length of arc PQ, length of arc PQ divided by radius of circle.
Yes.
Do you understand what I'm doing?
Yes.
So you can take a string, and using a string, you can see how long string you need to cover the arc, right?
Yes.
And you divide it by the radius of the circle. Okay.
That will be done.
So that will be a ratio, right? Correct.
Yes.
And notice that both of them are lengths. So both will have same unit, meter and meter. So the units will get cancelled, right?
Yes. Unit length.
So the angle that will come will have no units. It will be a unitless kind of thing, right?
Yes.
That is what we call angle in radians. Okay. Are you understanding?
Yes.
So from here, we get a new result. We get a new result that if I want to measure my angle theta in radians, it is equal to this length by the radius, right?
Yes.
This is like a definition. This is like how theta has been defined. Okay. If somebody asks you the reason for this, you cannot really give a reason because we don't have reason for definitions. Okay.
Okay.
In maths and science, when you define something, that is a judgment that you have made, you don't have a reason for it. Do you understand what I'm saying?
Yes.
This is the first basic thing that we have defined. After this, we will use it in different situations and we'll see how good our definition is, whether it makes sense or not, whether it is helping us or not. Okay.
Okay.
So the theta is measured as a ratio of the arc length and the radius. Now, obviously from here you can write a formula. L is equal to r theta. Right?
Yes.
And this formula will be useful for you even in physics when you learn circular motion and all. This formula will be useful to you. What is the arc length? That is equal to r times theta. But remember, when I write theta here, don't confuse it and write it using degrees. You cannot write degrees, okay?
Yes.
Because this unit was not using degrees, right?
Yes.
This unit was always defined in radians, correct?
Yes.
Okay. So we have this relation, but mostly we'll be working with this definition. Now, think about it. If, for example, my point went from P here all the way up to Q here, which is the other end of the semicircle. Okay.
Yes.
So basically, my arc will be this whole portion, right? Correct.
Yes.
The Q was not ending here, but it was going all the way till here. So my angle will be also this whole angle, right?
Yes.
So think about it. Theta would be equal to L by R. And the L in this case is the length of the
Pi R.
semicircle, right? Correct. So it is going to be pi r, right?
Yes.
Pi r divided by r is giving us how much? Pi, right?
Pi.
So we are saying that the angle in a semicircle is pi radians, right?
Okay.
Pi radians is equal to angle of 180 degrees, right?
Yes.
Because earlier we have already understood that this angle was called 180 degrees, right?
Yes.
Now we are representing it in different method and calling it pi radian. Are you understanding what I'm saying?
Yes, understood.
Similarly, if you took the point Q and put it all the way here, brought it to the point P again, right?
Not 2 pi.
Now it will be the full circle. So it will be L by R would be equal to 2 pi R by R. So you'll get 2 pi is your angle. So 2 pi radian is 360 degrees. Okay?
Yes.
So most of the time in trigonometry and in 11th and 12th maths, you will be using the radian measure for degrees. Okay.
Okay.
For angles, we'll not be writing, mostly we'll be using radians. And it is actually pretty simple. You just have to remember that pi radian is equal to 180 degrees. So obviously 2 pi is 360 degrees and pi by 3 is 60 degrees. And pi by 2 is 90 degrees. You just need to convert, right?
Yes.
All of these things will become pretty normal to you. You just need to get used to it. You have to use it enough number of times, it will become normal. Okay.
Okay.
Also, in 10th grade, you might have learned this table of values of sine and
Yes.
cos and tan, right?
Yes, sir.
Sine, cos, tan. And there is a table of values 0 degree,
30,
30 degree,
60.
45 degree.
Okay, sorry, sir.
What are you saying?
No, I jumped 45 and directly came 60.
These are the 5 values you would have learned in 10th grade, right?
Yes.
Sine 0 is 0, sine 30 is half,
Uh,
sine 45 is 1 over root 2, sine 60 is root 3 over 2, sine 90 is 1, right?
yes.
And cos 0 is 1 and cos 30 is root 3 over 2. This is 1 over root 2. This is 1 over 2. This is 0. And finally tan 0 is 0 because tan is sine by cos, right?
Yes.
You have to divide the sine value by the cos value. So tan 30 is 1 by root 3. Tan 45 is 1. This is root 3. And this is undefined or infinity, right?
Yes.
You have seen this table before, right?
Yes.
Do you roughly understand how the table values are coming?
Yes. Sir.
How do you think we
Pattern.
have found these values?
This value.
See, the basic way to find the values is like this. Take a right angle triangle. Okay. This is a right angle triangle. Let's say we have taken a 90, 45, 45 triangle. Okay.
Okay.
Correct, no?
Yes.
Now, if you take a 90 degree 45 triangle, and if you have theta here, you should realize that this is a right angle triangle, but it is also an isosceles triangle.
Yes.
Since it is isosceles, what we have is that these two sides are equal in length, correct?
Yes.
AB and BC are equal because angles are 45, right? So if you call this length as some A, this is also A, and because of Pythagoras theorem, the hypotenuse will be root 2A, right?
Yes.
So obviously sine theta is what now? Sine theta, which is theta is 45 degrees. Sine 45 degrees is A by root 2A, right?
That was one.
And cos 45 degrees is also 1 over root 2 because it is A by root 2A again.
Yes.
Correct? And tan 45 is 1 because it is A by A, right?
Yes.
So the reason the ratio came is because we use some geometric properties. We use the geometric properties of isosceles triangles, right? The angles are equal and therefore the sides must be equal. And then we use Pythagoras theorem, right?
Yes.
Are you understanding what I'm saying?
Yes, sir.
Similarly, you could have a triangle which is like this. This is 60 degree this is 30 degrees, and this is 90 degrees. And now this triangle, we also have to use some geometry to figure out what is sine 60, what is cos 60 here. Sine 60 here is AB by AC, and cos 60 here is BC by AC, right?
Yes.
Now, again, the way people have found out root 3 by 2 and 1 by 2 is by using some geometry. And what I would suggest is you try to prove this.
Okay.
You can try to do this as homework. I would give you the hint that it will come if you drop a perpendicular like this and see similar triangles ADB, BDC, and ABC. Triangle
Yes.
ADB, triangle BDC, and triangle ABC will all be similar. Do you know about similar triangles in 10th grade?
Yes.
So if I drop a perpendicular, you should be able to prove that these three triangles are similar. And if you can prove that the triangles are similar, you can write the ratio of their sides, right?
By triangular.
You will be able to write the ratio of the sides for each of the similar triangles, right?
Yes.
If you try it out from there, and at the end you also have Pythagoras theorem that AB square plus BC square is equal to AC square, right?
Yes.
You also have Pythagoras theorem for these small triangles. You can say AD square plus BD square is equal to AB square, and also BC square plus BD square is equal to BC square. So you have three statements of Pythagoras theorems, and you have several statements from the similar triangles, right?
Okay.
You should be able to prove that these ratios will be root 3 by 2 and 1 by 2. Okay?
Okay.
But I will leave it for you, you try it out.
Yes.
The
Sir.
reason I am telling you all this is because I want you to understand how that table came from. Okay, that table of values that you have learned, right? In 10th grade, they didn't tell you the reasons, right?
Yes.
Nobody asked you for the reason of why sine 30 is equal to half. But it is good
Yes.
if you know the reason why sine 30 is half, why cos 60 is half, and so on. And the reason is pure geometry in a 90-60-30 triangle. Okay. For tan 45, sine 45, cos 45, we took a triangle 90, 45, 45. That was pretty easy, right?
Yes. Sir.
Are you understanding what I'm saying?
Yes. Sir. Understood.
Okay, so this part, the proof of this, you should try it out and see if you are getting it or not. If you don't get it, we'll discuss it in the next class. Okay. The point that I want you to understand is explain how the values of sine 60, cos 30 and all came. Right?
Yes.
Okay. But now that we have learned about angles and we have learned about angles going from 0 to 2 pi, right? Or 0 degrees to 360
Yes.
degrees. The next step for us is to find out how to get the sine of 150 degrees or sine of 240 degrees or sine of 300 degrees or cos of 330 degrees. Do you understand what I'm asking?
Yes.
I want to be able to calculate the sine, cosine for angles from anywhere from 0 to 360 degrees. Okay?
Yes.
Because in general, trigonometry covers all those angles. So first of all, we learn how to measure those angles. The way the angles are measured is think of a circle like this. Usually we think of it as a unit circle. And unit circle means radius of the circle is 1. Okay. If you think of a unit circle, this is your positive x-axis. This is your positive y-axis. And think of the circle center as O, which is 0, 0. And think of this point as P. And if the point P moves from here along the circle, it can come to many of these points, any of these locations it can come, right? These are possible locations of point P, right? Are you understanding what I'm saying?
Yes, sir. Understood.
If the point P moves from here to here, then this angle determines where the point P is currently, right? Similarly, this angle is going to be from here to here. This is, notice that now the angle is above 90 degrees, right?
Yes.
Similarly, if the point P comes here, the angle is even more than 180 degrees. It is this big angle.
Yes.
If the point P comes here, the angle is bigger than 270 degrees, right?
Yes.
So the angle can be anything from 0 to 360 degrees, right?
Yes.
And that is how we think of the angles of in trigonometry. And you can also call all of these angles in terms of pi. So we'll say 150 degrees is basically 5 pi by 6. This is 4 pi by 3. This is 5 pi by 3. This is 11 pi by 12. Okay.
Okay.
You should realize that pi is 180. You can calculate and see all the calculations should be correct. Right?
Yes.
So our angles will be from 0 to 2 pi, right? Are you understanding what I'm saying?
Yes, sir. Understood.
Okay. Now, our ultimate goal is what? Our ultimate goal is to find sine of 4 pi by 3 and cos of 5 pi by 6, sine of 11 pi by 12. 11 pi by 12 is 330 degrees. 5 pi by 6 is 150 degrees. 4 pi by 3 is 240 degrees. I'm just writing these because this is the first time you're seeing it. So I'm just calculating it for you. But over a period of time, you will also get used to it. Okay.
Okay.
You don't have to actually write all the degrees and all. This is itself enough, right?
Okay.
Our job is to find out the sine, cos and all for these values. So the problem is that now we cannot use our right angle triangle, right?
Yes.
Because you can never get a 240 degrees in a right angle triangle, right?
Yes.
So obviously our 10th standard definition is not going to be valid anymore, right?
Yes.
What we learned in 10th grade of sine, cos, tan, we need a better definition of sine, cos and all now, right?
Yes.
Okay. So that definition is what we will now try to figure out. So take this circle. What I want you to tell me is if my point P moves from here, remember that this is a unit circle. Unit circle means radius is 1. So if my point P moves from here and comes to this point, which is at 120 degrees, okay, correct?
Yes. Sir.
This is x-axis, this is y-axis, and obviously origin is at 0, 0. This point O is at the origin, right?
Yes.
Have you learned about coordinate geometry and XY plane and Cartesian coordinates and all?
Yes. Yes.
So
Right.
can you tell me, can you find out the X and Y coordinates of point P right now?
X coordinate.
think about it, using all the stuff that you have learned so far, using your trigonometry knowledge and everything, and remembering that the radius of the circle is 1. So actually OP distance is how much? 1, right?
One. Uh, the x coordinate will be minus cos 60.
So how are you saying that? You can roughly draw a right angle triangle like this, right?
Yes,
And you can see that this angle is 60 degrees.
yes,
So this distance by 1 is going to be cos
minus,
60, right?
yes,
So the distance is actually equal to cos 60, which is half, right?
yes,
So this x coordinate will be minus half, right?
yes.
What is the y coordinate at this point?
It will be root 3 by 2 cos 2.
Okay, so you are able to find the location of this point P, and the reason you were able to find the location was because you knew the radius, you knew this angle, and you knew the table of values of sine and cosine, right?
Yes,
Are you understanding what I'm saying?
yes, sir. Understood.
Suppose now my point moved to this point. Can you tell me the x coordinate and y coordinate of this? Now the angle is 180 degrees by the way.
Yes. So x coordinate will be minus 1
Hmm,
and 0.
correct. Suppose the point moved to this point and you are at now 240 degrees.
Yes.
Find the x and y coordinates.
From the 270, we will find 30 degrees and make
No matter how you want to find it, it's up to you. But I just need the x and y coordinates of this point when the angle from this side is 240 degrees. Okay.
uh,
You can
the
find it
y
from,
coordinate.
tell me.
The y coordinate will be minus root 3 upon 2,
Hmm,
and the x coordinate will be sine 30 is half, minus half.
hmm, great. Similarly, suppose the point came here. What is the x and y coordinate?
0 comma
0 comma
1. Minus 1, sorry.
minus. Suppose you went to now 300 300 degrees. From here it is 300 degrees.
Yes.
What is the x and y coordinates?
Uh, x will be plus half and y will be minus root 3 upon.
So far, how are you able to find the xy coordinates? What is the method you are following? Tell me.
Basically, in 120 degrees, I find like 90. It is like I take 180 degree
Hmm.
and then I, I subtract it and then find by using right angle.
So the basic idea is you know the radius of the circle is 1 and you know the
Yes.
table of values of sine and cos from 0 to 90, right?
I'm trying to making it in a complementary angle.
So you know the sine and cosine values of any angle from 0 to 90. So you are making it a small angle and trying to find the distance, right?
Yes,
That is the method you are following, right?
yes,
And then you are finding the x and y coordinates of this point P. No matter where the point is on the circle, As long as you have the correct table of values of sine and cosine, you should be able to find it, right?
Yes.
For example, suppose I asked you the point was at 225 degrees. Can you find the x and y coordinates of this point? Radius is 1.
Minus 1 upon root 2 x coordinate and minus 1 upon root 2 y coordinate.
But in a different setting, it might not be so easy. Suppose I told you the point was at 117 degrees. What is the x and y now? The reason it is not so easy now is because we don't know the value of this 63 degrees, right?
Yes.
But if you check your calculator, you will be able to find sine 63 and cos 63 values. Do you understand what I'm saying?
Yes, sir.
If somebody gave you the table of values of sine 63 and cos 63, then according to you, what is the answer? X and y should be how much?
Means should I give you exact value or in a rough form?
No, I want the value in terms of this only. No, it will come in terms of this or not.
Yes.
X and y coordinates of point P will come in terms of what?
Yes, sir, in sine term.
So I
X
want,
coordinate
huh,
x coordinates will be minus cos 63 degree and plus sine 63.
this is the values that will come, right?
Yes.
So what we have learned so far in the last 5 minutes, whatever we have done, is we have learned that any point on the unit circle, we can find the x and y coordinates of that point, right?
Yes.
Okay. So now it should be very easy for you because the definition of sine and cosine has been developed like that only. Suppose you have a circle. Think of this as a unit circle. Any point wherever you are, no matter where you are, right? You are here or you are here or you are here. Let's say we are here first. This angle is my theta, right?
Yes.
The x and y coordinate of it is basically called cos theta comma sin theta.
Yes.
You understand what I'm saying?
Yes, sir.
What we have defined, cos theta is defined to be the x coordinate of the point P as it moves on a unit circle and makes theta angle with positive x-axis.
Yes.
Do you understand what I'm saying?
Yes, sir. Understood.
And sine theta is defined as the y coordinate of P.
Yes.
So far all the calculations that you did were you were actually finding the cos and sine values at those angles.
Yes, sir.
For example, we had the first thing that we calculated was what? When it was 120 degrees, right?
Yes.
First thing you told me was when it was 120 degrees, what is the x and y coordinates of this, right?
Yes.
And you said that it is minus half and plus root 3 by 2, right?
Yes.
So now you should realize that, okay, x and y coordinates of a point are basically cos and sine of that point where the angle is the angle that the point makes with the positive x-axis. So it will be cos 120 degree and sine 120 degree. Do you understand what I'm saying?
Yes, sir. Understood.
So cos 120 degree now we have learned is equal to minus half, and sin 120 degree is equal to plus root 3 by 2.
Yes.
And you should realize that the way in which you got this was we got it as minus cos 60 degree.
Yes.
That's what you calculated, no?
Yes, sir.
This you got it as sine 60 degrees, right?
Yes, sir.
So now this tells us another rule that cos of 180 minus 60 is minus cos 60.
Yes. Understood.
Because we have defined cos 120 to be this, no?
Yes.
Which is equal to minus cos 60, correct?
Yes, sir.
So we can say cos of 180 minus 60 is minus cos 60, while sine of 180 minus 60 is equal to sine 60, right?
Yes.
You will see this pattern happening many times. I'm just pointing it out to you right now. But what you should already realize is now we have a way to find any sine, big angles also. Sine 330 degrees, suppose somebody asked me, right?
So 360 minus 30.
No, first I'll draw my unit circle and first I'll locate my point, right?
Okay.
I'm not going to do some formulas and all. Please try to realize what I'm trying to teach you.
Okay.
I'm not asking you to learn some formulas.
Okay.
Do you understand what I'm saying?
Yes, sir.
The whole point of this explanation was so that you don't have to memorize formulas.
Yes.
How do I do sine 330 degrees? I will first find where the point is. You have to go 270 degrees till here and then 60 degrees further. So somewhere here, right?
Yes.
This full angle is 330 degrees. What have I learned about cos and sine?
Cos will be the x coordinate and sine will be y.
So if I need sine 330 degree, I need the y coordinate of this point, right?
Yes, sir.
So if this angle is 330 degrees, this much is 30 degrees, right?
Yes.
I will just draw a right angle triangle and I know radius of the circle is 1.
Yes.
So y coordinate is going to be basically negative. But what is the value? Sine 30 is y by 1, right?
Yes.
Y by 1 is sine 30. Sine 30 is half. So y is equal to half. But this is negative half.
Yes.
Do you understand how I found the value of this?
Yes, sir. Understood.
I am not doing any memorization. Many places in books and all, many places you will see that they will ask you to remember things like sine 360 minus theta is minus theta, minus sine theta, sine 180 plus theta is minus sine theta. I'm not asking you to remember anything.
Yes.
What I'm saying is find whatever angle you're looking for, find the location of that point, find the x and y coordinates of those points, right?
Okay. Okay.
The x and y will give you the cos and sine, right?
Yes.
If you know the cos and sine, obviously tan is easy.
Yes. Sine.
Tan is basically sine by cos. Once you know any ratio, all the other ratios can be found. I hope you know that.
Yes, sir.
So if you know sine and cos, you can find everything else, right?
Yes, sir.
So that is how you learn about like basic trigonometric angles. And now we have expanded our list of angles that you can find out from only till 90 degree to any angle from 0 to 360 degrees, right?
Yes.
Okay, so that's about it for today's class. I will share with you the homework that you're supposed to do. The homework will be from the SLONI book. Okay,
Okay.
so
And that proof question.
what?
The proof question
That
that
proof
you.
question plus. there will be some extra work which will be from the SL only book.
Okay.
So I will tell you by today evening and all. I will check the book once and let you know what you should try.
Okay.
Which exercise you should do, I will tell you in a couple of hours.
Okay.
So try it out. We will be spending the next few weeks on trigonometry, but if you do the homework properly, you will be able to finish it easily and understand everything. You just need to follow what I'm telling you. Okay.
Yes, sir.
Okay. That's all for now. I'll see you on Wednesday.
Thank you.
Bye.